This is the NEET 2016 question in kinetic theory of gases. It says 1 mole of an ideal monoatomic gas undergoes a process described by PV power 3 equal to constant. So you need to understand this thing first carefully. PV power 3 equal to constant. In an adiabatic process, in isothermal process, PV is constant. In adiabatic process, PV power gamma is constant, where gamma for monoatomic, diatomic is something like 5 by 3, 7 by 5, or 8 by 6, or something like that. This is completely different. This equation is different. This kind of a process is called polytropic process. The process in which multiple processes can happen simultaneously is called as polytropic process. The relation between Cp and Cv in polytropic process is different, and we have derived it in our regular playlist. Please go through that. I would like to tell you that the relation there between Cp and Cv is the C, not at a constant pressure, equal to Cv plus, regularly we have Cp equal to Cp minus Cv equal to R, so Cp equal to Cv plus R. But here it is R by 1 minus alpha, where this is alpha when PV power alpha is constant. So in our case, alpha is given as 2. Right, so this is a new relation that we need to know. I have made this derivation in my regular playlist of kinetic theory of gases. You can go through the derivation and understand that from where you are getting it. Right now, I'm not deriving it for the convenience. And he is asking us in the problem to find out this C, the heat capacity of the gas during this process. So what he is asking is this: heat capacity of the gas. So for that, I need to know what is Cv. Cv equal to, we have a formula, F by 2 times of Nr, where F is degree of freedom, N is number of moles. It is given that number of the moles equal to 1. Being a monoatomic gas, degree of freedom is 3. It can have only a translatory motion. It can move along x-axis, y-axis and z-axis. Hence, degrees of freedom is 3. So I can say the Cv value is 3 by 2 times of R into N equal to 1. That is 3 by 2 times of R. Once you know Cv, I can get the C, heat capacity, C as Cv plus R by 1 minus alpha. Cv is 3 by 2 times of R plus R by 1 minus alpha is, as PV power 3 is constant, alpha is 3. So this is 3 by 2 times of R plus R by minus 2. That is 3 by 2 times of R minus R by 2. 2 is LCM, 3R minus R is 2R. Also, 2 gets cancels, R remains. So R is the answer for this problem. This is how we solve this problem. So to solve this problem, we need to know this expression, that for in a polytropic process, relation between C and Cv. I have made this derivation as I have told you. Please go through the playlist and find the derivation so that you can understand that how do we derive that relation itself. That's it, and thank you for watching.